Hare Krishna. Good evening, everyone. After a long time, we're meeting. The topic for today's discussion on Python would be packing and unpacking values. In the previous last 5 or 6 sessions, we have seen data structures like lists, tuples, sets, and dictionaries. So we already know what packing is. So let us take an example. We'll create a tuple 1, 2, 3. So this creates a tuple for us, and A is a reference to the memory location where the tuple is stored. So if we need to see the memory address of the tuple, we can use the inbuilt function id and we can provide the object A, and it returns us the memory address where. So this memory address is basically where this object A is pointing to. It acts as a pointer to the memory address, and at this memory address the values are stored. The values are stored here. So we can even wrap it with another function called hex that will give us a nicely printed hexadecimal address for us. A hexadecimal address for us. So on the right hand side of the assignment, this is an iterable. So basically it means that it has the ability to iterate over, and it has the ability to store multiple values. So essentially what we are doing is that we are just packing values into this object A. So the reverse of this is unpacking. The same stands true for any data type. And you can see the hex ID of A, and this time A is an object that is referencing or referring to a different memory location where this object 1, 2, and 3 are stored. So this memory location and this memory location are totally different. So this is packing, which we already know. So let us now talk about unpacking. I'm using Jupyter Notebook. In the previous sections and sessions, I used Visual Studio Code, but now I prefer more Jupyter Notebook over to VS Code. So unpacking, let us take an example of a tuple. This. Okay, now we need to unpack values. So we can use statements like B, C, D equal to A. So on the right hand side of the assignment is the tuple, and on the left hand side is also a tuple. So on the right hand side, the tuple consists of 3 elements, 3 items. So the first item 1 will go into B, or B will refer to that first item. C will refer to the second item and D will refer to the third item. And if you print B comma C comma D, we can see 1, 2 and 3 we got. Or we can do it alternatively, like if we want to see the value of B, so B is 1, C is 2 and D is 3. In order to run your commands, press shift and enter on the cell, and the current cell statements will be executed. You must remember the fact that tuples are not created because we place a parenthesis. So this does not create a tuple for us. So I mean to say that 1, comma 2, this is a tuple. Is also a tuple. So a tuple, in order so that the tuple can be created, the comma is essential. So since both are of type tuple T1 and type T2, both are tuples. Both are tuples. So even strings can be even strings can be unpacked, or in general any iterable can be unpacked. We can make our own iterable too. So let us suppose that there's a string called hello. So I can use the statement called a. So on the right hand side is the string S. This refers to some memory location where the object hello is stored. There are 5 elements into it, and according to the previous things which we saw, so H will go into A and B will refer to E and so on. So if you type A is H, B is E, C is L, D will again be L, and E will be O. So I hope this is clear to you that any iterable can be unpacked. So because any iterable can be unpacked, so sets and dictionaries are also iterable. So it means that they can also be unpacked. So let us see an example. But please keep in mind that set and dictionaries, the order is not important here. They are orderless. By orderless, I mean they are non-sequence type. Whereas strings, tuples, and lists, they are sequence type containers where the order is important. The way you put elements into the container, the way it goes into that. But there's no guarantee when you're using set and dictionaries. So let us use a set. Let us make a set, and so this is a set. So if we want to see the type of set and the ID of the object S, refers to this memory location, and this is a set. So let us now try to do the same thing, unpack values from this set, but the order is not guaranteed. So as there are 4 elements on the left hand side, so we have to use equal number of literals, and now let us use the print statement. So we get A as A, the value of A is A here, the value of B is B. Now you see the order in which we place the elements in the container, and the order how we unpacked it and how we got the element is not guaranteed. So now in this B literal, it stores this B, the value B, C gets 1 and D gets C. So set can also be unpacked. Likewise, dictionaries also can be unpacked. So let us see a quick example of how to unpack a dictionary. So let us create a dictionary called D, and let us give a key, value 1, comma, key 2, value 2. So now this dictionary essentially consists of 2 key value pairs, key 1 and key 2. The values are value 1 and value 2. You can see the type of dictionary and the ID of dictionary. Okay, so it shows that it's a dictionary, and this is the memory address where this D references to, or it points to this memory address. So now let us do the same thing, unpacking. So A comma B equal to D. Let us see what happens if we use the same print. We get the keys. On unpacking, we only get the keys. So we got key 1 and key 2, but we did not got the value 1 and value 2, but on unpacking we just got the key. So we'll see on the later section how to get all these values, the values too, in fact. So where it is used, it is normally used, I'm very sure that you all have come from very different backgrounds with different programming language experience. So if in other programming languages like C, C++, or JavaScript, if we need to swap some values, let us suppose A equal to 10 and B equal to 20. So I need to swap these values. So in normal case, what we do is we create a temp variable and we store the reference of A into this temp. It means that temp is pointing to the same memory location where A is pointing. Now we'll give, now A is pointing to the memory location where B is pointing. And lastly, we'll make temp. So if we now see a comma b, print a comma b. So we got 20 comma 10. The values have been swapped. So what happened here was the reference, the address to which a points, temp is also pointing to the same memory address. Likewise, here now a is pointing to the memory address where b is pointing to. So now essentially if we access the value of a, it will be 20. And now finally what we did was we made temp to be pointed to b. It means that now b is referencing to the same memory location where temp is referencing. So temp is referencing this a. So essentially b has the value of 10. So now let us try to see something more, some more examples. If you have any questions, please do ask. So there are quite a lot of uses of this unpacking. Let us consider a list of with so unpacking can be done in different ways also. Let us create a variable a equal to. Now this will consist of the first element, only one, and b will consist of the list, and it will start from the index position 1 and go till the end. So in order to make it clear, uh, my list, okay. Now if you print a comma b, or if you try to see the contents of a and b, so we'll see that a has the value of 1, whereas b has a value of all these within the list. So a only has the type of value a consists is of integer, whereas the type of value b is pointing to is a list. To further expand this, let's copy the code here. Okay, it is already there in the global namespace. So we got this 1 2 3 4 5 6 7. We can also use a different format altogether. So what this means, star means. So on the right hand side is an iterable, a list. So the first element on the left hand side, the first object a, will reference to the first element 1. This is not a problem. What star b means is the rest. The rest will be all taken by b. So whatever rest is left will be taken by b. So now if we go and see the value of a and b, we see the same result as above. So star will essentially means the rest. So now let us take another example where there's a list called again my list equal to 20 comma minus 3 4. So on doing this, I hope you should be able to now answer or understand what will go in A and B. So A will consist of 20, the first element, and the rest will be taken by all. The rest all will be taken by this B literal. So this B literal will be pointing to this object, the entire object. So if we run this, you can see A has the value of 20 now, whereas B has this value. We can also do something like copy this entire code here, paste it, and see. Okay, so now what should be the output? What happens is that the first element goes into this literal A, the last element goes into this literal C, and the rest, which is this one, will go into this B or unpacked into this. So we can see A has the value 20, B has the value of list of all these items, and C has the string hello. But star can only be used once in a statement. So if we try to attempt the same thing here and use star C, so it gives an error to us. Multiple starred expressions in assignment, and this is very logical. Why it's logical? Because star means rest. So why are we using two when we are already specifying star here once? So it means that it will take the rest entire thing which is left. So there's no need to give another star here. So let us take an example of something like, okay, so I'll try to reduce a literal. So this is an iterable. This can be unpacked, which we have seen. So what happens is A will point to P. It means that P will get stored in A, not stored in A actually, but P is stored in a memory location where A is referencing to. B will hold the second, or it will refer to the second element, and the rest, which is THON, it will go, or it will be referred by the letter D or the object D. So if we try to print, just see A, what happens? A is P, B is Y, and D is the rest, THON. So remember the fact that when you use a star, you'll always end up in a list. So to make this point even more clearer, let us first try to create tuple. Okay. So now it is eventual that A will have the value 1, B will have the value 2, and the rest which remains will be in C. So if we now try to see the contents of C, A, B and C, what happens is that we got 1 and 2, okay, but the contents in C is essentially a list, but originally it was a tuple. So it has been converted from a tuple to a list here. Uh, okay, so we can see it individually here as well. A is 1, okay. We can see the type of A is int, B and type of B int, and C and type of C. So this is a list. This is a list. So when you use a star operator in an expression while unpacking, it is always important to understand that this will always return you a list no matter how you started. So now let us try to see some more examples. And its usage. List 1 equal to so we can also use the star operator on the right hand side. So let us see what happens if we use it. So star list 1. So now we are packing and star list underscore 2. And now if we see the contents of L, we'll see 1, 2, 3, 4. So now this is packing values into a container object, and this container object is a list that points to some memory location. So here the values are unpacked because list 1, star list 1 will always give you a list, and star list 2 will always give you a list because star is there. Let us see some more examples. Now list 3 equals Python. If we see the contents of list 1, it's 1 and 2 right now. List 1 is 1 and 2. So we'll use this now. We see the contents. You can see the list has been extended. So the values has been unpacked first and then packed into this list. Now we already know that set and dictionaries, they are unordered. So there's no guarantee that we get the same thing when we unpack things, which we have seen. Now let us take an example of some dictionaries. So dict1 equal to, so there are two dictionaries, dict1 and dict2. So let us try something different. We'll try this unpacking of dict1 and unpacking of dict2, and then try to see what L has for us. So now L essentially has a list of strings or characters, but we started from dictionary and we ended up in a list. So this is the usage and the examples. You can dig more into it, and in later sections and in later sessions we will indeed dig more into it when we'll see functions, when we'll encounter functions and all. We can also use the star star operator, and this is also an unpacking operator. So let us see an example of this. We'll copy the same thing here, paste it here. Now we are using these dictionaries, star star dict1 comma star star dict2. So now this gave us a collection, a single collection of a dictionary with keys of both the dictionaries in a single dictionary and the values as well. But this star star operator, this unpacking operator, cannot be used on the left hand side of the assignment operator. So this thing you should keep in mind. So to see some more examples, let us now you are unpacking the entire dictionary D1 into this D2. So let's see what happens. So we got A, the value of A, the key A is 1 and the value of key C is 3. But why not 10? So, because this was evaluated first and Python assigned the key A to have a value of 10. And later on this was evaluated by Python. And it's okay, now A has a value of 1. So it overridden this value 10 to 1. But C is essentially the same. So we can see it here as well. So if you can reverse this thing, okay. And now let's see. Now A has a value of 10 and C has a value of 3 because this expression was evaluated first, and according to this evaluation the value of the key A is 10, so 10 is there, but it did not overwrite A is 1 because here A is 10 as well. Now if I try to change this to 100 for example and rerun the program, we'll get end up in A to be 100 because now this has been overwritten. Likewise, so this was all about packing and unpacking. If you wish, this code can be shared to you, and you all guys have to submit the assignment on the next session, which will be held on Friday. So thank you guys. I'm just waiting for your questions. So I hope that nobody has any questions. So we'll meet on Friday, the same time. Thank you so much for joining.